Okay, welcome back. I've been asked to do a few questions. This is General Maths, Chapter 13A.1 in relation to indices. Okay, so here's a few questions I've asked to do. I've asked to do particularly the latter part of question 7 and also some of question 8. I've also included the laws of indices, which if you haven't got memorized, they're definitely worth your while to have on hand because you'll be using some of these as we do it. Now, some of the easier questions for chapter 7. Now, we've learned that powers, so something like we know if we do 3 to the power of 2, well, that's 9, 3 to the power of 3 is 27, and so on. And we also know things like negative powers. You can write 3 to the power of -2. That is 1 over. So the -2, 1 over 9. Turn on my 9s. All right. Still got to write my 9s a little bit better by hand. Okay. All right. So these numeric ones shouldn't be too difficult if you recognize your powers of 3. So 3 to the 1 being 3, 3 to the 2 being 9, 3 to the 3 power of 3 being 27, and 3 to the power of 4 being 81. All right. Other ones you may not be too familiar with. Now, anything to the power of 0 is 1. So 3 to the power of 0 is 1. That's the answer for 7 part I. Okay. But then some of the algebraic terms might be a little more difficult. So if I take 7j, for example, 7j, all right. So I have 9 times 3 to the power of p. Okay. Now, if you look at the laws of indices, you notice that you have bases and you have other operations. So a to the m times a to the n. A to the m divided by a to the n. A to the m bracket then to the power of n. For a lot of ones here, there's a common theme. Either for the first few, the base has to be the same, or in the latter ones, the power is the same, like the power is acting on different parts. When it comes to these ones, we have to make sure the base is the same to the power on the bottom. So for example, the first part you could do here before you had to carry out any rules is express this as 3 to the power of 2 times 3 to the power of p. Then that becomes 3 to the power of what as silly as that. Okay. 3 to the power of 2 plus p. And all I've done is I've just used that first rule in the laws of indices. There's a similar one with k, 7k. All you have to do is recognize that you have 3 to the power of x divided by 3 to the power of 1, which is 3 to the power of x minus 1. Okay. Yeah, that's the second rule. Now with L, you actually have to use a combination. So L was the last one in question 7, so it is there to be a bit of a challenge, but I'll show you how to do it. First of all, you have to write the first part in terms of 3, but you got 9 to the power of this stuff. So I'm going to replace you have to be careful with this. The 9 has to be written as, let's put a little divider in here so I don't mix up my workings. All right, 7L. It's 3 times 2 to the power of n plus 1. There's a lot of leeway to make some mistakes here. And then we've got 3 to n minus 1. Okay. Then we're going to use essentially on the top. So I'll replace the 9 with 3 squared, but 3 squared then to the power of n plus 1. And then I have to use the third rule to expand what's there. So what's on top will actually become 3. And I have to use the distributive law. So it's 2 times n and 2 times 1. So it's 2n plus 2 divided by 2n minus 1. All right, then you have to carry out an operation with the second rule, and just be careful you're subtracting all of the power of the numerator. So it'd be 3 to the power of 2n plus 2 minus bracket 2n minus 1. Oops, I wrote a plus. Minus 1, which becomes, well, 2n minus 2n, that's gone. And you have 2 minus negative 1. It's actually 3 to the power of 3, which reduces to 27. There we go. All right, so that's how you do those ones. I was also asked to do question 8, so we'll get a couple of those. All right, just give myself a little bit of space. I still want to see question 8 there. All right. All right. Now in question 8, we're going to be using particularly this rule a lot. Also, we have some reciprocals as well. So I'm going to do a couple of them. 8a. All right. Okay, the idea is that the power of 2 acts on the numerator and the denominator. As such, you end up with 2 to the power of 2 is 4, and 3 to the power of 2 is 9. All right. Let's take one with a negative power. So let's do e. Now the power of 1 doesn't do anything, but the power of minus 1, well, in terms of irrational value, it actually flips the fraction. So it'd be 5 on 2. Now I'm going to take L, because that actually does incorporate everything. Now, all these ones are expressed as a mixed number. You have to write them as a improper fraction first. If you don't, and you try to carry out the powers, you're going to come up with problems, because what they represent is actually, it's not 1 times a half, because the powers have to do multiplication. And the problem is, if you write a fraction this way, it means 1 plus a half. So you have an operation of plus going on with powers, and it's complicated. So I'm going to take L. So the first thing you have to do is you have to recognize that's 3 plus a half to the power of minus 2. Got done there. Okay, and we're going to write this improper fraction. So if I had 3 oranges and I cut them into halves, how many halves do I have? Well, I'd have like, okay, each orange would have 2 pieces because you cut in half. So you'd have 1, 2, 3, 4, 5, 6, and another half, which would be 7 halves. Okay, so we've just changed the format of that. So now I've written that as an improper fraction. Now this format is a lot easier to do with indices. We can apply the negative power, flip that upside down. Do that first. So now it's 2 sevenths. I'll write that a little bit better, looks like kind of like a 1. Still looks like a 1. Okay. And then that's squared. So I flip the fraction, I've removed the negative power. All right. And then I will square that, and I will end up with 4. And 7 squared is 49. That is that. You need to be able to do those by hand, but you can check them on your calculator. But the idea will probably just come out with a decimal. And if the goal is to write them in the simplest rational form, so make sure you answer the question correctly. If you can't understand, okay, what is that fraction that goes on for that decimal that goes on forever? How does that look as a fraction? Well, you can't get back to this format. All right, so have a go at some of the other ones yourself if you haven't already, and I'm going to leave this video here.